So in this problem, what we're going to do is we're going to use our binary variables to help us make a decision about where to place an airport hub. So we'll start. Western Airlines wants to design a hub system in the U.S. So each connecting flights to and from cities are within 1,000 miles of a hub, and the company wants to determine the smallest number of hubs that it needs to cover all its cities. So let's go to the model page here, and you can see that I've already given you all of the distances between the different airports. So Atlanta, Boston, Charlotte, I'm not sure what DE is, probably maybe Delaware, Houston, LA, Nolans, New York, Pittsburgh, St. Louis, San Francisco, and Seattle. Actually, DE would be, I'm assuming that'd be either Detroit or Denver. So 1,300 miles from Boston, I guess Detroit. And so up here we have our 1,000-mile limit. So what we're going to need to do then is we're going to have to put something together to figure out how we're going to use things as a hub. So down here, this is going to be my binary variable. So which cities are used as a hub. So it's going to be binary because there's only two choices, 1 or 0. So we'll do binary variable. 1 is going to be a hub, otherwise 0, no hub. So no hub. Okay, so this matrix is going to be our potential hubs. And so how are we going to do that? Well, we are going to take a look at everything and see if it's within 1,000 miles of the other city. So, covered by a potential hub. I said it is going to be a hub, but it's covered by a potential hub. So, if there was a hub in Boston, would it cover Atlanta? And no, it wouldn't, because Boston's 1,037 miles away from Atlanta. So what we're going to do is let's write an if statement. And actually, before we do that, let's make a couple range names. So we'll grab mile limit, because that will be 1. And we will we'll grab used as a hub so we can see both of those. So data, formulas, create from selection, left column. Let's grab actually total hubs too, because we're going to try to minimize that. And then I want to get, these are going to be our constraints, hubs covered by, hold control, and required. Create from selection, top row. So that gives us all of our range names that we're going to need. So there's range names, come back here, control B to bold that, and using formula, paste names, paste list. Okay. Okay, so let's go back here. And part of the reason I did that is I'm going to use this mile limit in my formula, and I don't want to have to lock it in. So we're going to write an if statement. So if, what's that test going to be? Well, I want to know, is Atlanta, actually that's probably a bad place to start. Let's go for the Boston one. So if I want to know if Boston is less than or equal to that mile limit. So if it's less than that mile limit, we want to put in a 1 for a hub or a potential hub, if not 0. And so what this is going to do is this is going to let me know which cities would be served by the hub if it was there. So I'm going to control C that, and since I've got the range name in, it'll all index. I'm just going to control V across that entire thing. And then we'll move that to the middle. Actually, since I did that, it kind of messed up my formatting. So we're going to go no border and then all outside border. So these numbers are all indicating whether or not, okay, so if I have a hub in Atlanta, is Houston going to be serviced? Yes, because Houston's within 1,000 miles. If I have a hub in Atlanta, would LA be serviced? No, because it's greater than 1,000 miles. And it's tagged back into this number up here, so that way, if we change that number, everything will change for us. Okay, and so from there, all I have is I have my different hubs, which will be my binary variable. So we're just going to go here and I'm going to sum product. Whether or not I'm using something as a hub, comma, and so this would be which cities, which hubs are going to cover Atlanta. Well, I'm going to take whatever hubs I've got, and then I'm going to highlight it by, or sum product it with that row showing me which cities could be a potential hub from Atlanta. So if I do that right now, I have nothing. Let's throw down one hub in Charlotte. And there we go. So we got one. And so I'm required to be covered by one hub. So we're going to say greater than equal to and 1. And then from there, I just take that. I can drag all of those down. I'll have to fix that. Let's just double check one of these equations. It is indexing the way that I wanted it to because I used as a hub as a range name. So these other ones roll down. So just put in 3 ones here. You put in 3 numbers. Excel will recognize a pattern, and I can pull that down for ones. Okay, so now I've got up here which cities will be covered by a potential hub, which cities have a hub, and then how many of the cities are actually serviced by a hub. So now we'll go into data, we'll go over to solver, and we'll start our stuff. So our objective is going to be the number of hubs that we have, and we obviously want to minimize that. Changing variables. What variables can we change? Well, we can change which cities we are using as hubs. So that's our choice. And we do have a constraint. We've only got one constraint. Number of hubs has to be greater than or equal to the required hubs. Now, I just lied because I said one constraint. We do have 2 because these also have to be binary. So we're just going to come in there and go binary. Alright, so we're trying to minimize total hubs by changing what we're using as a hub. Hubs covered by has to be greater than required, and the used as hub has to be binary. So we've got all that in there. We will hit solve. The objective cell must contain a formula. I forgot to put the formula in there. So see, it's not going to work because your decision variables have to be tied to your objective. And that's easy enough. So we're just going to sum up all of these. And that's directly connecting our decision variables to our objective. And then all this is already filled in, so we're good. So now we'll hit solve, and we'll see if it works. And we'll hit OK. So in this solution, the best case scenario is I've got to use 3 hubs: Atlanta, Boston, and St. Louis. Every other airport's within 1,000 miles of that. And you can see that we're all covered by one, except New York and Pittsburgh get luxury treatment because they're covered by 2 hubs each. Okay, so let's say that the company decides that they've got some better jets, and 1,000 miles is a little too restrictive. Let's say they want to have their airport network set up to where any airport is within 1,500 miles of a hub. Well, it's easy enough since we set this up in such a way. I will just go put in 1,500 here. My matrix will automatically change, and I just go into solver, set total hubs, hit solve, hit OK, and there you go. We are reduced to now only 2 hubs, being Atlanta and Denver, or Detroit, whatever that one's going to end up being. And there we go. And then this works. We can just keep changing. Let's say that they want to be a regional jet. They want to be within 500. We just make the change, hit solver, hit run. We pop up 7 hubs. And that's the nice thing about having those range names, having it locked in. This is also another reason why you never want to bury numbers into those Excel cells. But there we go. That is how we would use this. If you have any questions, please let me know. Otherwise, I will see you in the next video.